So question 1 on your unit test just says for each circle write the required measure, and for A it said write the diameter. It gives you the radius of 11 centimeters, and then we see here, so we have 11 centimeters. Well, the radius is half the diameter, so multiply by 2 we get 22 centimeters. For B, 9.5 millimeters they show as the diameter because it goes all the way across. And it's asking for the radius. Well, the radius is 9.5 millimeters divided by 2 equals 4.75 millimeters. The only real trouble anybody had with this one was they didn't get the units right. Okay, they put centimeters for B instead of millimeters, so you will have lost a little bit on that, but you want to, but really pretty well done. So question number 2 for the test, we've got our formulas that we needed. It asks us for find the circumference of area of each circle in question number 1. So there's the circle still. And here's my formulas. I think, I didn't really see, I'm trying to think who wrote down all the formulas right away that I just saw. You could have just written them down so you have them to make it easy. So circumference equals pi times diameter, area equals pi r squared, or pi times r times r. So for A, we've got circumference equals pi, 3.14 times 22 centimeters because it's the diameter, okay, equals 69.08 centimeters. Circumference always in units. They got the area, pi times r, which is 3.14 times 11 equals 379.94 centimeters squared. Okay, area is always in units squared. So that's A. And for B, well, we've got the whole diameter, so pi times 9.5 equals 29.83 millimeters for the circumference. Area equals 3.14 times 4.75 times 4.75 equals 70.84 millimeters squared. Now your answers might be a tiny bit different depending on how you round it for pi. Other than that, they should be all the same. So I marked anything correct that was in the general vicinity. So for question 3, it says, use 1 centimeter grid paper. A, draw a triangle with area 12 centimeters squared. B, draw a parallelogram with area 18 centimeters squared. I don't have the grid paper, but I've got it here. One thing that people didn't do was they didn't label it. They drew these parallelograms but never put the measurements. So I had to count them, and then some places you got it wrong. So here we've got a triangle, and I've got the area here. Formula, area equals base times height divided by 2. Okay, I got my base of 4 centimeters, my height of 6. So I've got area equals base times height divided by 2 equals 4 centimeters times 6 centimeters divided by 2 equals 24 centimeters squared divided by 2 equals 12 centimeters squared. If you need to show all your work, so many people just drew one or didn't give me all this other stuff. Always give as much as you can, because then if you make a little mistake, you're going to get marks. A lot of people got no marks because they didn't put a lot of extra work. So for B, a parallelogram is that much simpler. Base times height. Got a base of 6 centimeters and a height of 3 centimeters equals 6 centimeters times 3 centimeters, 18 centimeters squared. Now, what a lot of people did, on not necessarily on this one, but other ones, this, I don't know what this is, but say this is 4.2 centimeters, this side right up and down here. That's got nothing to do with it. That's not the base, that's not the height. Okay, so that doesn't enter into it. So when later on, when there was that measurement provided, people were using it. That's nothing to do with it. It's base times height. Okay. So for question 4a, it says it's got this parallelogram, and it's an area equals base times height for our formula. Okay, but the problem people had here was they didn't put the right numbers in. A lot of people didn't put the right numbers in for base or for height. So the base here, it's tilted, but here's the base. This is the information. We've got the base here and the height here. Okay, so it's here at 7 centimeters times 3.6 centimeters equals 25.2 centimeters squared. Okay, 4.6. Okay, this is not the base in this case because, I mean, if we wanted to draw like an extension. Oh, let's see here. An extension of that line. Okay. And do the height here, then you could, but you know what? That doesn't give us that information. So it's 7 centimeters times 3.6 centimeters is A. So for question 4b, we've got this triangle and they want to know the area. Well, area of a triangle equals base times height. Now what's the base here? We've got a lot of numbers in this one, okay? So you have to kind of think. So right, looking here on the bottom is the base. Now the base isn't from here. It's not from here to here, okay? It's from here to here. So the base is 2 centimeters. Now what's the height? So the height is not from here to here, which would be 4.3. It's not from here to here, which would be 3.2. It's straight up from the base. So the height is 3.1 centimeters. Okay, and then we're going to divide it by 2 centimeters. And sorry, the area equals base times height over 2. My mistake. So we got 2 centimeters times 3.2. Well, this one's pretty easy to work out. These two cancel each other out. Okay, not the centimeters squared though. So now it's 3.1 centimeters squared. That's the answer for 4b. So 4c, it's more of an irregular shaped polygon. So and I know we talked about this in class, so most people did this, reasonably well as far as the strategy, but had trouble getting the right answer. So basically what you got to do is divide this thing into 3 different shapes. So I'm going to go right here like this, and now we've got this triangle. I'm going to draw right there. We've got this triangle here and then this rectangle. So let's start with this rectangle. 8 centimeters, rectangle, times 2 centimeters. So this portion in here, okay, this portion here, it's 8 centimeters times 2 centimeters equals 16 centimeters squared. Okay, so now we're going to go here. Well, I didn't draw this very well to scale, but you can see on here it says from here to here is 4 centimeters. But if you go the whole way, it's 8 centimeters. So this is supposed to be half. And I didn't draw it very well, so my apologies. But you can tell, so that means this area right here is 4 centimeters. Now, if you look at it this way then, okay, if this either way, if you say this area right here is your base, okay, and base equals 4 centimeters. If that's 4, then here, all up here, is also the height equals 4 centimeters. You could do this both ways, right? You can make this your base here, make this your height, it doesn't matter. Okay, so we've got 4 centimeters times 4 centimeters, but it's a triangle. So you got to divide by 2. Okay, equals 8 centimeters squared. Okay, now we've got this little triangle here. Now what is the height? What's the base? Well, look over here on this side. You can see right here, it says this distance from here to here is 2 centimeters. So we're going to use that as the base. Base equals 2 centimeters. So if that area right there, that distance is 2 centimeters, and then the height here is 1 centimeter. We've got, and the area is 2 centimeters times 1 centimeter, and of course divided by 2 equals 1 centimeter squared. 1 centimeter squared plus 8 centimeters squared plus 16 centimeters squared equals 25 centimeters squared in total. Okay, that is 4C. So question 5A and B, it says, so 5, the Rosano family decided to put a patio in their backyard with a flower garden beside it. What is the area of the flower garden? So we have on here the garden. No, I didn't write it on here. So it says garden. So we see it's 8 meters. The whole backyard is 8 meters by 4 meters. We can see here it's 1 meter, 2 meters, 3 meters, 4 meters. So right here we can see, okay, you know what? If that's the base, that would be 2 meters. Okay, because it's 4 and we're halfway across. Now what about here? Well, that's going to be 8 meters. So we've got, down here I wrote the area of the garden equals base times height over 2 equals 2 times 8 divided by 2 is 8 meters squared. So there's our area of the flower garden. But now what about the patio? Well, to get the patio, first you need to get, because the patio is basically the whole backyard except for the garden. So, well, we've got the area of the garden at 8 meters squared. So we need to figure out the area of the whole backyard first. So that's 8 meters by 8 meters, okay, base times height, 32 meters squared. But now that's the whole backyard. We only want the patio. Well, like I said, everything except for the patio, except for the garden, sorry, is the patio. So you take the area, 32 meters squared of the whole backyard, minus the area of the garden, leaving you with 24 meters squared, and that is the area of the patio. Okay, so number 5C was basically nobody got this right. I don't believe anybody got this one completely right. So it says each patio stone is square with side length 30 centimeters. One stone costs $1.95. It says how many stones are needed for the patio? Well, we've got the area of the patio, we know, is 24 meters squared. Okay, now how many of these stones are going to be there? Now how do we get the area of a stone? Well, say that, right, it says that they're 30 centimeters. They're square, so it's each side length 30 centimeters. Well, for right now, let's pretend it was 1 meter. Okay, so the area of one stone would be, if it was 1 meter, would be 1 meter times 1 meter equals 1 meter squared. Okay, and that's, I know people, so it's one, if it was 1 times 1, get 1 meter squared. And that would give us the thing. But the areas, the side length is not 1 meter, it's 30 centimeters. So 30 centimeters, how many meters is that? So right now we're dealing in meters, so we got to get this into meters. So 30 centimeters, okay, well, there are 100 centimeters in a meter. Okay, so, and when we do our calculations, we see it's actually 0.30 centimeters. Meters. I erased that. So each side length is in meters is 0.30 meters. Okay, so then we have to go, well, how do we get the area of this using that? Well, same as we did when we were pretending that the side length was 1, we multiplied 1 times 1 to get 1 meter squared. Same thing here. 0.30 meters with one side length times 0.30 meters, yeah, another side length, equals 0.09 meters squared. Okay? So now, one stone is 0.09 meters squared. Well, how many meters squared is the patio in total? Well, we know it's 24 meters squared. So how do we figure out how many of those will go in? Well, if it had been up here, the 1 meter squared, how many stones 1 meter squared would go to 24 square meters? Well, you could say, okay, well, 24. 24 divided by 1. But we're not here, we're dividing by 24 divided by 0.9 meters squared. Okay. So when we do our calculations on that, we got 24 divided by 0.09 equals 266.6 repeat stones. Well, generally speaking, they don't. You got to buy whole stones, so we'll say it's 267 stones. Okay, and what assumptions did I make? Well, I made assumptions that, when I have like, say I have this stone, if I'm trying to fit in a shape like this, in the patio, that I can chip. You can use half a stone here and a quarter stone here. I can reuse little bits of the stone to fit into the shape. Okay. Then it asks us, how much will the stone for the patio cost? Well, we know, okay, that it's $1.95. Okay, it says up here per stone. So if there's 200, oops. If there's 267 stones, we multiply that by $1.95, okay? And we get the answer of $520.65. And that is C. So for question 6, it says 20,000 fans were in attendance at a hockey game. The table shows the results of a survey that asked fans to state their favorite hockey team. It says how many fans cheer for other teams, and I'm going to write the thing down here, but there's 20,000. We know there's 20,000 fans, and it says there's 2,000 Montreal Canadian fans, 5,300 Toronto, 7,500 Vancouver, 1,500 Edmonton, Calgary, 1,100 Detroit, 1,200, and then it says other. So how many other fans cheer for other teams? Well, when we added up all the fans for those teams that were listed, it came up to 18,600. So all we simply had to do was 1,400 fans for other. Okay, so that was done really well by pretty much everybody. And it says, write the number of fans for each team as a percent of the total number of fans. Well, if we have, say, Montreal fans, we have 2,000 fans out of 20,000. Okay, well then we need to just remember this line here, okay, means division. So we can even divide by 10, divide by 10, divide by 10. So we got 2 out of 20. Thinking like, well, what percentage is that? When you go 2 divided 10 by 20 equals 0.10. And if you want to write that as a fraction, you can write it as this, or as a percent would be 10%. Okay? So that was for Montreal. So I'm going to do, so Toronto was 5,300 over 20,000. Okay, and that works out to be 26.5%. Okay, Vancouver is 7,500 over 20,000. Okay, this equals 37.5%. Now some people, I guess, rounded off and they rounded down, which wasn't, if you're going to round 0.5 it would go up. But you need to keep these up for percentage because it needs to add up to 100. So that was Vancouver. Okay, now we got Edmonton. So they had 1,500 over 20,000. And that equals 7.5%. Okay. After Edmonton, we had Calgary, 1,100 over 20,000 equals 5.5%. We go up here. Okay, and then after that they had Detroit, 1,200 over 20,000, and that works out to be 6%. And then the other, which is 1,400, okay, works out to be 7%. Okay, so that's all the things for 6B. Okay, and I'll move on to 6C. Okay, so for 6C, it asked you to do a percent circle or a compass, protractor, and ruler. Draw a circle graph to display these data. So a lot of you chose the fraction circle, okay, which was all in all pretty well done. So I just wanted to go over percent circle. Just going to go over the other way. Okay, so we wanted to do using a compass. We have to figure out how many degrees each one. We know what percentage. So Vancouver is 37.5 degrees. Okay, but a decimal, remember a decimal can be, so it could be 37.5%. That's a percentage. 37.5 over 100 as a fraction. Okay, or 0.375 as a decimal. Okay, so here we've got our circle. So I've got I got a radius here to start from. I'm going to go, and you remember I have this little tool, so it says, so I'm going to go over, so there's 90, so from 90 I need to add on 45 to get to 135, so 40, so this would be the biggest chunk. Okay, it's going to be Vancouver. Okay, so now we go back on. We got to go. Well, let's say the next biggest chunk, starting at, you're using a compass, say at 55, and we want to go 26.5. Well, so that's going to be, from there is going to go all the way to 30. Oops, sorry. So at 55, it's 5, 10, 15. Oh, I'm sorry, we want 95 degrees. Never mind. Here we go. So we got 55, 45 is 10, 35, 20, 25 is 30, 15 is 40, 5 is 50, and then we know that's now we're at 55. Okay, but we want to get 95, so we got to go another 40. Okay. And that is Toronto. Okay, so we can just keep going from there. So now so now we've got Montreal, which we've calculated to be 36 degrees. Okay, so we're starting at minus 40, so they're going to take us to 76. Okay, so that is going to be Montreal. So now we've done Vancouver, we've done Toronto, we've done Montreal. Okay, so now we got to do 075 is going to be, Edmonton. So we're going to go looking for 27 degrees. We're at minus 27. So 87 is 10. 90. Start again. $87 is 10. So now we've got to go another 17 from 90 would be 73. Okay. And the way I'm doing this may be a little more confusing for you guys because I've got this tool for the things and you guys aren't using it. But anyway, I'm just going to stop there, and I think that's enough for how you guys can do that other than the percent circle. Okay, so I'm just going to erase this and just quickly go over what a percent circle would look like. Okay, so here's my circle. Okay, and basically to do a percent circle, I've got this here. I'm going to put that in the middle. Okay. So I've got 1. And then what you're going to do is you're going to get 100. Okay, so every line would be kind of like 3.6 degrees. 2. So there, for example, if you had to do this is approximately 1, 2, 3. That would be 4 degrees. Okay, so that's what you do your degrees and you can go over. But we can do that in class if you have any other questions, because I think that was fairly well done. So the last question just simply says, write 2 questions you can answer by looking at the table or the graph. Answer your questions. So you could say which team had the most fan support, which 2 teams added up to about a quarter. There's lots of different questions. So that one was well done, so I'm not going to go over that. So that's all this for your test. Alrighty.